Good morning, everyone. Myself, Dr. Prashant Yadav, Department of Physics, Janta, Vedic College, Baraut, Bagpat. Today, I am going to present the topic Introduction to Quantum Mechanics. This topic is mentioned in UG 5th semester syllabus. So, first we start from classical mechanics. So, the first question come in our mind: Do the electrons in atoms and molecules obey Newton classical laws of motion? So frankly, we can say that no. So we cannot explain the electrons in atom and molecules by the simple laws of classical mechanics. This phenomena is led to the development of quantum mechanics. So prior the quantum mechanics, there are various scientists like Galileo, Newton, Lagrange, Hamiltonian, Maxwell, shows that the behavior of any particle which can be explained by the mechanics. So if if you have any object, any particle, we can easily identify its position, momentum, energy by using the simple classical phenomena laws which were developed by these various scientists. So everyone is studied in up to the 12th standard. M d square upon r d square r upon dt square is equal to f, where m is the mass of the particle and d square r upon dt square is the velocity of that particle, and f is the force which is applied on that particle. So by this formula we can easily identify these physical quantities. But as we says, the electrons in atom and molecules then do not obey the simple laws of mechanics because we cannot see the electrons. So how we cannot define the position and the momentum of that particle. So this limitations or this failure of classical mechanics led to the quantum mechanics. The first phenomena observed by the scientist which shows clear disagreement with the classical mechanics is black body radiation. So what is black body? A black body is a theoretical object that absorbs 100% of the radiation that hits it. Therefore, it reflects no radiation and appears perfectly black. And vice versa, it's also a perfect emitter of the radiation. So, at a particular temperature, that black body would emit the maximum amount of energy possible for the temperature. So, a black body is a perfect absorber and a perfect emitter. So, it absorbs and emits all kinds of radiation, all types of radiation. So we can understand by this the black body phenomena by the variation of energy with temperature. We can easily understand by this example. So when we heat an opaque object, it shows deep red color. But when we increase its temperature, its colors turn reddish orange. When we heat this substance more, it colors turn yellowish white. So by increasing the temperature, the color of the metal is increasing. So by this experiment, we can draw the graph which shows that as the temperature increases, the energy peak shift to the higher frequency side, which shows that the energy emitted by the black body is increasing as the temperature is increasing. So for explaining this graph, Rayleigh and Jeans drive in a formula which is not showing the agreement with the higher wavelength side. So this is known as the ultraviolet catastrophe. So for explaining this phenomena, Planck introduced a concept. For this, Planck get the Nobel Prize in 1918. So Planck introduced the concept of quantum or a quanta. So Planck basically describes the energy is quantized, means energy is transferred, it's emitted and absorbed only in terms of packets or bundle, and every packet and bundle has the energy h nu. So energy can be exchanged in terms of packets or bundles, and every packet and bundle have the energy h nu or multiple of h nu, wherein delta is equal to n h nu, where n is the any positive integer. So higher frequency light only emitted if thermal energy kT is greater than equal to h nu. So as the temperature increases, the energy frequencies increases. So h nu, a quantum of energy, where h is Planck constant, nu is the frequency of the body, which is frequency of the body atoms which emitted the energy. So the particles, the atoms, the molecules of that body vibrate from a certain frequency mu, and which frequency they vibrate only absorb and emit that frequency range radiation. So they shows that the radiation is absorbed and emitted in terms of bundles, and this bundle is known as quantum of energy. When h tends to zero means when h goes zero, the quantum mechanics turn into the classical mechanics. So the conclusion from the Planck quantum theory are: energy is quantized, not continuous. Energy can only exchange by well-defined amounts. So before the quantum mechanics, before the Planck concept, it it assumes that the energy is continuous. It can exchange in a continuous form or a manner, but Planck introduced the concept of quantization of energy. Energy can only be exchanged in terms of packets or bundles. A second phenomena which shows that the classical mechanics cannot explain the all phenomena which happens in the universe is photoelectric effect. What is photoelectric effect? When a photon of certain amount of energy h nu is incident the metal surface, it ejects the electron from that metal. So this phenomenon is known as photoelectric effect, where h nu is the energy of incident photon, phi is the work function of the metal surface. So when the incident, when the photon is incident on the metal surface, so it's based it's some energy to in work function, and remaining energy is taken by the electron as a kinetic energy. So no electrons are ejected unless mu exceed a threshold value characteristic of the metal. So every metal have their characteristic threshold value, means below this energy we cannot emit the electron from that metal. So this threshold value is vary from metal to metal. So if we incident the photon below the frequency of threshold value, we cannot emit the electron from the metal surface. If we incident the energy in a continuous time or infinite time to the metal, we cannot eject the electron if this frequency is lower than the threshold value. So before the quantum mechanics, before the Planck concept, it's assumed that if we incident the energy, it absorbs in a continuous manner. But this not happen in the case of photoelectric effect. If the energy if the energy is below than mu, means the energy frequency is below than threshold value, that we cannot emit the electron from the metal surface. So light only can be absorbed in terms of quantums or in terms of packets. So we can understand by this example, red light ejects slower electron than blue light. We know that red light energy is lower than the blue light energy. So when the two photons are incident on the same metal surface, the blue light photon emit the electron has the high kinetic energy compared to the electron emitted by the red light energy. So this shows that higher the energy, higher the kinetic energy of the electron. So it shows that the energy cannot be exchanged in terms in a continuous manner. So we can exchange the energy in terms of quantum or packets. These packets are called quanta. So we can explain that the classical mechanics has the limits. So this clearly shows by the photoelectric effect, which cannot be explained by the simple classical mechanics. So the classical mechanics is assume that the particle and the wave has a different aspect. Means particle and waves are different phenomena. But according to the quantum mechanics, photon, the particle and the wave are the dual nature. So in the 1920s, it was becoming apparent that sometime matter can behave like wave and radiation can behave like particle. According to quantum mechanics, a matter can behave like a wave and wave behave like a particle. So in black body radiation and photoelectric effect, we have seen that the photon behaving like a particle, but the de Broglie introduced a concept in 1924 which shows that the matter also have the wave nature. It shows that the lambda, it calculates the wavelength of that wave which is associated with the particle. So he used the formula lambda is equal to h upon p, where h is the Planck constant, p is the momentum of the particle. So by this applying this formula, we can easily calculate the wave associated with the particles. Every moving particle have associated a wave, which concept is proposed by the de Broglie in 1924. This phenomena shows that the classical mechanics have certain limits and quantum mechanics can explain these phenomena which cannot be explained by the classical mechanics. So thank you for listening. Have a nice day.